yesterday we got a chance to play the computer game. Today what we want to do is make sure we understand what exactly is happening in the computer game and how it connects to photosynthesis.
What we decided to do is to see if analogy mapping techniques might be effective in science instruction that uses digital games.
They were very eager. They really like jumping in. You know, we're playing this because we're eventually going to use it to understand something bigger.
We spent a year pilot testing the games, the instructional materials, and the professional development with middle school science teachers. That pilot testing allowed us to create the treatment condition that we're using now in our study. We also have a comparison condition in which students use the games, but teachers do not use the analogy mapping techniques. We're comparing student learning across these two conditions to see whether analogy mapping techniques are effective tools for helping students learn challenging science concepts.
We created an instructional sequence in which teachers and students connect the games to the target content using discussion questions and visual images to support the discussion.
You're expected to look at this particular game, break it down into its component parts, look exactly at what each part represented, and then put it all together and go, oh, so that's how this worked together here, and it is analogous here in this other example.
How is this breaking up carbon dioxide and water? How is that related to sunlight and how it relates to photosynthesis?
We need sun to break up all these molecules to make them individual.
Okay, that makes sense to me so far.
Then they take all these individual atoms, they're making glucose.
So they need to make glucose.
Yeah, and
That's the only thing photosynthesis makes.
No, oxygen.
Since plants need carbon dioxide, if we breathe out, we actually help them by giving them carbon dioxide.
We use what plants make, plants use what we make. It's almost like it's one big cycle.
Finally, we were able to kind of make the connection that this was a very large cycle. And Stephanie, who was sitting nearby, you could actually see it on her face. She was starting to connect the dots of how a plant produced something that was essential to our needs, and we produced something that was essential to the plant's needs, and also related to the game that we were doing. That kind of inference followed by discussion, followed by realization is the essence of what any good science class or any good discussion would involve.